All right. Let's look at the review sheets. Are there any questions on problems 1 or 2? Questions on 1 or 2? Number 1. Now, with any of these here, especially on the test, one of the things that you need to pay attention for is a greatest common factor. Now, not every problem on the test will have a greatest common factor, but if it does, you need to factor it out. If there is one, you need to factor it out. I will make the greatest common factor 1 point on the test, so most all of them are worth 5 points total. If you are able to factor it down and don't pull it out, that's fine, because you'll get 4 out of the 5 points, but you'll lose 1 point for the greatest common factor. If there's not one, there's not any points to lose for it. So whenever we look at these problems, so this one here, we'll look to see if there is a greatest common factor. And well, there is, because if we look at all 3 terms, they do have an a and b in them. So we can factor it out. Now, if we look specifically, well, the first one is a cubed, a, and a squared. So the most that we can pull out of all 3 terms is, well, a. B, on the other hand, we have b squared, and b squared. So we can factor out a b squared from all 3 terms. Now, if we look at the rest of the numbers themselves, well, 6, 36, and 71 do not actually have a greatest common factor. So the most we can pull out of any of these 3 terms is ab squared. So for the first one, we would still have our 6. And if we factor an a out of a cubed, we remove 1 from 3. We have a squared, 2 of them left. B squared factored out of b squared will factor out completely. We have minus 36. Since we didn't do anything to the numbers, we didn't factor out a number, we can go on and just put it back. If I factor an a out of a, well, it factors out completely. And b squared factored out of b squared would factor out completely, so all we're left with is minus 36. Plus 71. If I factor an a out of a squared, I'm left with a, and the b squared factors out completely. Now at this point here, I'm going to rewrite this in standard form, so we would have ab squared times 6a squared plus 71a minus 36. Any questions on this here so far? Now at this point here, we can check to see if this is factorable, because it looks a little weird. And actually, if we checked our 71 squared minus 4 times 6 times negative 36, we do get a whole number. And that whole number is 64.629. Goes on. So really what that's telling us is that this here is as far as it goes. The quadratic inside the parentheses are 6a squared plus 71a minus 36 is not factorable. We cannot factor it. This is here. On the test, there will be some that the only thing you have to do is pull out a greatest common factor, but what's left inside the parentheses should be very visible that it won't factor any further. I'm not any of the ones, so to flesh that out a little bit more, because this here, 6a squared plus 71a minus 36, that does look like it has a chance of factoring, yes? So we could have some that only have, say, 2 terms, and we can kind of see it a little bit clearer, or other ones like that.
Can you give us the
b squared minus 4ac?
what is the whole thing?
This? Because I can't give you the whole number, because it's a non-repeating, non-terminating decimal. Any other questions on 1? Any questions on the first 2? First problem number 2. Now, when we look at this here, we have 36x squared minus 49b. Is 36x squared and 49b squared perfect squares? Because what times itself is 36? Well, x times x would give us x squared. And what times itself is 49? 7. So what that tells us that this is a difference of perfect squares. So we'd have our 2 sets of parentheses. We would have plus and minus, because difference of perfect squares would be the opposite signs. And we said 36x squared would be 6x and 6x. 49b squared is and 7b. Because it's going off the fact that a squared minus b squared is equal to a plus b times a minus b, or in either order. And it would be good to just make sure that there's not a greatest common factor between those. X and b is not a greatest common factor because they're not the same variable. And well, 7 is prime, so there's not going to be a greatest common factor there. Questions on this here? We're good with 1 and 2. Questions on 2 and 3? We want to look at either one of these here. If we feel good with 2 and 3. Questions on 4, 5, 6, or 7? Number 5. 8x squared plus 6x minus 27. So the first thing we need to look for is the greatest common factor between these 3 terms. And well, there's not one. So we can go to our 2 sets of parentheses with 3 spaces. Since the 27 is negative, our signs are going to be opposite. One's going to be positive and one is going to be negative. Now we're going to look at the factors of 8x squared and 27. Well, x squared is going to be x and x. Now the factors of 8 are 1 and 8, or which one do we want to try first? 2 and 4. Now 27 is 1 and 27, or 3 and 9. Which one do we want to try first? Well, we'll go 3 and 9 and plug them in there. Check to see if this is correct. 2x times negative 9 is negative 18x. Plus 3 times 4 is 12x. Negative 18x plus 12x is negative 6x. So since the middle, we got the correct number but wrong sign, we flip the signs. So we can change the 9 from being negative to positive, and change the positive 3 to negative 3. And this here would give us the correct answer. Any other questions on this here? Any other questions on 4 through 7? Number 7. Now this here we need to see if this is the actual sum of 2 cubes. So we can see if we can take the cubed root of a cubed and take the cubed root of 1. Now the cubed root of a cubed is, and the cubed root of 1 is 1. So that does tell me that we can take the difference of these two cubes. Now, when we look at the signs for the sum or difference of perfect cubes is going to be the same, opposite, always end on a positive note. So the same would be plus, opposite would be minus, and always end on a positive note would be plus. So for any of the sum or difference of perfect cubes, we will always have two addition signs and one subtraction. Now for our first set of terms, we're going to be dealing with A, since it came first. So in the first set of parentheses, we would just have A. In the second set of parentheses, we're going to have A squared, A to the first, and the last one would be A to the 0. But anything to the 0 power is 1. Now for our second set of terms, we're going to be dealing with 1. So we would have 1. Now next to the A squared, we would actually have 1 to the 0, which is 1. So we don't have to put it in. Middle term, we're going to have 1 to the first. And lastly, we're going to have 1 squared. So what that leaves us with is A plus 1. And well, A squared is A squared minus 1 times A is A plus 1 squared is 1. So not a whole lot changed, mainly because A being squared and 1 being squared really is just going to give us A squared 1. It really didn't change a whole lot. But this factored is A plus 1 times A squared minus A plus 1. And that's it. So any other questions on 1 through 7 on the first page? If we're good with the first page, let's look at look and see if there's any questions on 8, 9, 10, or 11. Questions on 8 through 11. 11. So when we look at this here, most likely there is a greatest common factor. Now looking at these three numbers, well, I can see that there is an x squared because all three do have the variable x. And whenever we're factoring out a variable, we're really taking out however many the least one has. Since x squared is the least or the smallest, we can at least take 2 out of every one. Now, looking at the numbers, I know that 49 and 7 both have a greatest common factor of 7. It would be nice if 343 also had a greatest common factor of 7, which it actually does. So we can factor out a 7x squared. Now, 7x squared factored out of 49x to the 4th would be 7x squared. Plus 343 divided by 7 is 49x plus 1. Because if I factor 7x squared out of 7x squared, I'm left with 1. Anytime anything factors out completely, it is going to be 1. It will not just disappear completely. We still need that 1 there. And that's actually it. Because there's no way that I can take the factors of 7 and the factors of 1 and somehow multiply those factors together, multiply and add them together, and get 49. It's just way too big. So this here is done. And if we did take the square root of b squared minus 4ac, we would see that we would get a decimal answer. So this is as far as it goes. Any questions on this one here? Any other questions on 8 through 11? Or one that y'all want to look at? You feel good with these here? All right. Questions on 12 through 15. Questions on any of these here, or one of these that y'all want to see worked? Feel good with 12 through 15? All right. Questions on 16 through 18. 16, 17, or 18? Any questions on any of these here? All right. Questions on 19, 20, 21, or 22? 22. Now, the first thing we can do is try to take the cubed root of these two numbers here and see if they are perfect cubes. Because if they are, then we can do the sum or difference of perfect cubes. And since most likely x cubed is telling us that there is one, but there might be a greatest common factor. Now, looking at this here, there is a greatest common factor of y, because I can't take the cubed root of y, but luckily both terms do have y in them, so I can factor it out. Is there anything else we could factor out of these two terms? Well, I do know they're both even, yes? So we can factor out a 2. I'm having a little trouble seeing anything other than that, so let's start with 2. And if there is another greatest common factor, we can see it from there. So if I divide both of these numbers by 2, this here we would get 1, 5, 6, 2, 5x cubed minus 4, 6, 6, 5, 6. Okay. Now we can try to take the cubed root of these here and see if that works. 15, 6, 2, 5x cubed. Well, the x cubed will come out as x. And if we take the cubed root of 15, 6, 2, 5, we get 25. So we can go on and take the cubed root of 46,656. And if we do that, we get 36. So we do have the difference of perfect cubes here. So on the test, again, we're not going to have any that are not factorable. So if we do have a cubic x cubed or x cubed and y cubed as our terms, I would be looking for perfect cubes. If it doesn't work on the first set of numbers, factor it out and try again. Factor out a number. Also, if we had tried 31,250 and it didn't have a perfect cube, it means the other one won't either. Because if I have to factor something out to make it a perfect cube, I need to take it out of both. I can't just take it out of one. So if this doesn't have a perfect cube, it automatically means this one doesn't either. But now that we have this here, we can set up our sets of parentheses. Now our signs are going to be the same. Opposite always end on a positive note. So since the starting one was subtraction, our first sign will be subtraction because it'll be the same. Hold on. Next one is opposite, so it would be plus. Always end on a positive note would be plus. First set of terms we're going to plug in is 5x. So our first thing here would be 25x. The first set of here we'd have 25x squared Yes, 125x, and then 25x is 0, which is 1. And the second set of parentheses we're putting, or the second set of numbers is 36. So here we would have 36. We don't put anything with the 25x squared, but in the middle term we would just have, in the last one we'd have 36. And lastly, we need to simplify. So the first thing we're going to have to do is take 25 squared, which is, I want to say 625. 625x squared. Plus, we're going to do 25x times 36. Well, 25 times 36 is 900x plus 36 squared is 1296, I think. 36 squared. I mean, that's a little impressive, but I also just did this not 30 minutes ago, so I can remember some numbers for a little bit, other numbers not so much. If you ask me about 36 squared in about 2 months, I'd have to look it up. But that's all we have to do for this here. Any other questions on this one or 19, 20, 21, or 22? So we feel good with these 4 here? Okay. Questions on 23, 24, 25, or 26? 25. 25 is a little bit different because this time we have 4 terms instead of 3 or 2. So we're looking at factoring by grouping. For most all of these here, we can group the first 2 and second 2. We can group those together to find out what the greatest common factor is going to be between them, and then factor it out again. So if I look at 5v cubed and 5v squared, or 25v cubed, there is a greatest common factor of 5 squared. Because 5 will go into both 25 and 5, and v squared will go into both v cubed and v squared. So if I factor 5v squared out of 25v cubed, we're left with 5v. Because 25 divided by 5 is 5. And v squared factored out of v cubed is left us with v. Plus 1. Yeah, the 5v squared will factor out completely from 5v squared, which leaves us with 1. Plus. And we're going to put plus because we're not factoring out any signs or negatives. And we want to look at the greatest common factor between 30v and 6, which is 6. 30 divided by 6 is 5, and we have our v. And 6 divided by 6 is 1. Because whenever we do this here, we need the sets of parentheses to be the exact same. So we needed them both to be 5v plus 1. And now that we have them the exact same, we can factor it out of both. And if I factor 5v plus 1 out of the first, I'm left with 5v squared plus 6. And that's it. Now again, with any of the terms inside the parentheses having a degree greater than 1, so we're looking at the v squared plus 6, we might want to just double check and make sure it won't factor again. But this one here won't factor because the only time we have 2 terms in it factoring is if it has a difference of perfect squares. So this one won't go any further. Any other questions on 26? Okay. So we can look at the first 2 and second 2. Now looking at these first two, I do know that I'm going to take out n squared, because the first one has n cubed, the second one has n squared, so it does have a greatest common factor of n squared. Now we need to find a greatest common factor between 105 and 175. I know one number I know in particular would be 5. So we can try this here. Now, if it works out that both parentheses don't line up and there's another greatest common factor, we can pull it out and try again. Now, if I factor 5n squared out of 5n cubed, well, 105 divided by 5 is 21, 1n, plus 175 divided by 5 is 35. And the n squared would factor out completely, yes? Okay. Let's look at the second set. Well, most likely it's going to be a little difficult getting 75 to 21, so we might have to factor something else out of it to get it to where we need it to be. But if I look at 75 and 125, there's two things that I notice. One is that they are both what? Negative. So it tells me I'm going to have to factor out a negative, because the first set of parentheses, both numbers are what? Positive. So if I need the parentheses to be the same, both numbers in both parentheses at this point need to both be positive. Because here, 21n and 35 are both positive. So whatever comes out in these parentheses here, both need to be positive. And since we're starting out with two negatives, we need the negative to come out. Now what will go into both 75 and 125? Huh? 5. I think there's actually something bigger. 25. Because if we did 5, I don't think it would have made them the same. But let's go on and take 25, because what time, or 70, let's start that again. Negative 75 divided by negative 25, well, the negative and negative would make a positive. 75 divided by 25 is 3, and we have n. For the negative 125, well, the negative and negative would make a plus. And 125 divided by 25 is 5. Okay. So, are both sets of parentheses the exact same? Because one of them, I have 3n, and the other one I have 21n, yes? So what times 3 is 21? Okay. Then the other term we have is 5 and 35. Wait, what's 7 times 5? 35, yes? Well, if I look back at the first one here, 21n and 35, is 7 a greatest common factor? Well, yes, isn't it? So what that tells me is that 5, really, it is a common factor, but it's not the greatest. So what we would need to do is factor out a 7 with it. So we have 7 times 5n squared. Well, 7 divided by 21 would be 3n plus 5. Okay, minus 25 times 3n plus 5. So really that just told us we had another factor to pull out. Now, 7 times 5 is 35n squared times 3n plus 5 minus 25 times 3n plus 5. I did that just so we can have the one term, so we're not trying to do two steps at once. Just the 7 times 5. Now, both of these do have a greatest common factor of 3n plus 5 times 35n squared minus 25. So, are we completely done? No. If you at least got to this point here, you would get 4 out of the 5 points. Yes, we do have a greatest common factor between 35 and 25, which is 5. So if I factor the 5 out of these two here, I'm going to put it out front, because that would leave us with our 3n plus 5. Well, our 35 divided by 5 is 7n squared minus 25 divided by 5 is 5. And that's it. Now the 7n squared minus 5 won't factor, even though it does have the minus, because we would need both terms to be perfect squares. 7's not a perfect square, and 5 is not a perfect square. There's no two numbers, whole numbers that multiply together to give me 7 or 5. So that's as far as we can take it. Any questions on this here? Let's look at these two. Is there one of these in particular you all want to look at? $27. Well, if we look at this here, well, we only have how many terms? 2. Well, they do have a greatest common factor, yes? Because I do see that they both have x, so I can factor out an x squared, yes? Do they have a number in common? 12. So I can factor out a 12x squared from both terms. So if the factor 12x squared out of 12x cubed, well, 12 will factor out completely, and x cubed would become x. Because if I have 3 and take 2 away, I will have 1 left over. Minus, because we didn't pull out any signs. 144 divided by 12 is, and the x squared will factor out completely. Now the 12x squared outside does have a degree greater than 1, so we could look there, but how many terms do we have there? 1. It won't factor. That's as simplified as it gets. Inside the parentheses, the degree is 1. So that's it. All we had to do is factor out that greatest common factor, and we were done. What would it be for the other one? And factor out a 15x, leaving with x plus 2. Come on. There we go. And that's it. That's all we'd have to do. Any questions on any of this here? You know what? Let's do one more just for fun. I'm kind of in a factoring mood. Let's say x to the 4th minus 2x squared plus 1. Let's try doing this one here. I know that it's 4th and squared, but we could do kind of 2 sets of parentheses with 3 spaces. Since the third term is positive, our signs are the same and they match the sign of the middle term, which is negative. So we could say negative and negative. We'll get to x to the 4th in a minute. What would the factors of 1 be? And 1. Now the factors of x to the 4th. So we can say x times x cubed or x squared times x squared. Which one do you think we would use? Well, what's our middle term? 2x squared. Well, that means that this one's not going to work, because if we're adding those middle terms together, I can't add x and x cubed and magically get x squared. So the first terms have to be x squared and x squared. Now we can check it here and see if this works. Or I can just erase the multiplication here and the multiplication here. X squared times negative 1 would be negative x squared. Negative 1 times x squared is negative x squared. And negative x squared minus x squared is negative 2x squared. Is that the middle term that we wanted? Well, yeah. So it factored, yes? Well, what's the degree of both of those sets of parentheses? 2, isn't it? And we have a subtraction. Well, is x squared a perfect square? Well, yes. Is 1 a perfect square? So are both of these the difference of perfect squares? So are we done factoring? No. X squared minus 1 is going to become what? X and x minus 1, yes? Wait a minute, over here. What are we going to have? X plus 1 and x minus 1. Because they're both difference of perfect squares, so they'd factor like that. Just thought that was interesting. Any other questions on any of the other problems on the review sheet? Well, if there are no other questions on any of this here, we'll be done for